Welcome back to the Thoughtful Techie Cloud YouTube channel. I'm Greg Powell, and today we're going to talk about AWS managed databases. We're going to look at comparing and contrasting how it was in the past to have to manage the full stack of your database versus AWS managed databases. But before we do that, we're going to jump into the big data problem and define that. So in case you haven't realized it yet, there is unprecedented data growth right now. There's an explosion of data. Why is that? Because everybody is on the internet and everyone has connected devices on the internet, whether it be your smartphone, which is constantly generating data. Think about all the applications on your phone. Imagine all the YouTube videos that are being uploaded. Imagine all the people on YouTube uploading videos and creating comments, people writing blogs and what have you. There's a constant explosion of data that is nonstop. Think about the Internet of Things and smart homes and smart light bulbs, smart cars. It is just incredible how much data it is. And the old ways of managing this data just don't work. Let's look at modern application architectures, such as microservices. Think about the hundreds, if not thousands, of microservices some sophisticated customers have that run in the cloud. And each one of those microservices either needs to consume data or is generating data that gets pushed to other upstream systems. Now, thirdly, think about rapid change, how data is constantly changing, how requirements for how data is consumed is constantly changing, and just how architectural patterns shift from time to time. We need to find a way to wrestle with this. And the way to wrestle with that is to figure out how to strengthen your databases and specifically your database architectural patterns. It's important to note that application architectures have evolved all the way back in the day till mainframes. Mainframes are very legacy these days, although occasionally you will find somebody still using a mainframe. I don't know of anybody that wants to use a mainframe. It's usually the case that the legacy application is so intertwined and wound up in that mainframe, and there's very few people that still have the skills remaining to do it, that for some, it's easier to just keep the lights on. However, at some point, you have to find a way to unwind that and figure out how to tease that information and data out of that mainframe and get it into the cloud. After mainframes, there was a client-server model. Now, when I came into the information technology industry some 20 years ago, I know it's crazy to think about it. I've been doing this professionally for 20 years. And then before that, as a preteen and a teenager, I was your average computer nerd, although I like to feel as though I was above average. I used to have teachers that would call me out of my classroom in middle school and high school to come either fix the local machine in the class, or either the librarian would call me into the library to fix and troubleshoot the local area network. Yes, this actually happens. I've been doing this for a while. So yeah, client server used to be a server, and then you had some sort of laptop or desktop nodes that would have a client-server relationship. Then there were three-tier architectures. This was the web or presentation layer, the application or business logic layer, and then the database layer. Now fast forward to 2022, and we have microservices. So instead of having monolithic architectures, now you have small services that are maintained by two pizza teams that do a small subset of things really well. And these microservices usually have an API front end that you can interact with them. And so these are very sophisticated architectures that are representative of a modern application architecture. Now, there are many aspects to a modern application architecture. In this video, we're going to focus on databases. So prior to managed databases, self-managing a database was complex and time-consuming, and it still is. You had to concern yourself with the hardware and the software installation, the configuration, the patching, and the backups. The lift of how to do all that was on you. Anytime you wanted to improve performance or address high availability issues, guess who was responsible for that? You are. Now, in terms of capacity planning and scaling clusters for compute and storage, guess who's responsible for that? You guessed it, you again. And then security and compliance, whether you're trying to maintain or achieve PCI compliance or HIPAA compliance or FedRAMP or SOC 2 or any number of these certifications and accreditations, that is all on you. So self-managing those databases is very, very difficult. And there's a lot of undifferentiated heavy lifting on you to be able to figure all that out. But guess what? There's a better way, and that's AWS Managed Database Services. Now, where I want to point your attention to is on the left. Let's look at self-managed. And if you self-manage a database, all the things you have to do starting at the very bottom of the stack. The very bottom of the stack, you have to figure out and build into your architecture what the best practices are. You also have to perform routine maintenance. Monitoring, you're going to have to set up that monitoring all by yourself. Patching, you have to set up patching. And if you want to automate it, that's even more of an engineering lift. Push button scaling, there really isn't push button scaling when you have to maintain it yourself. Sometimes there's a lot of manual intervention. Sure, you could probably write some scripts to do that, but you have to ask yourself, wouldn't your time be spent better off doing something else? What about those industry compliance requirements I was telling you about? If you're maintaining the full, complete stack and it's not a managed service, you're responsible for every layer of the compliance from the ground up. What about isolation and security of the database? Figuring out encryption, data at rest, data in transit, and those types of things. You have to do that. Backups and recovery. Wow. You have to do that too. Automatic failover. Good luck with that. Schema design. Now we're starting to get up to the things where a database engineer and a database analyst would start doing. Schema design, query, construction, and optimization. That is what differentiates your business from everybody else. But when you self-manage it, you're having to contend with the whole stack. And as you can see by the emoji there, a lot of tears are being shed. Let me know in the comments if you're self-managing databases right now and you feel the pain. Let me know if you know what I'm talking about. Okay, so for the fully managed side, guess what? When you consume managed AWS database services, AWS handles the best practices, the routine maintenance, the advanced monitoring, the automated patching, push button scaling, industry compliance. Now that is a shared responsibility model. So you're still going to have to make sure that you're selecting the right options to achieve the compliance, but AWS has baked into the database services the features you need to be able to achieve the respective compliance. Please refer to the AWS documentation for details on specific compliance requirements. The isolation and security, backups and recovery, and automatic failover are all a part of the AWS Managed Database Services. So think about this for a minute. All of that undifferentiated heavy lifting is removed. And again, undifferentiated heavy lifting is anything that you had to do that didn't differentiate you from your market and competitors, but it just had to be done to keep the lights on. That is all removed by AWS as your cloud provider, and you focus on what makes you innovative, and that's the query optimization, the query construction, and the schema design as an example. And speaking of AWS managed databases, here's something else that is awesome. You have to pick the right tool for the right job. It used to be historically, before AWS Cloud, what most people would do is select a relational database management system to do everything. So that relational database system was a jack of all trades. Even if the data model wasn't transactional in nature, that's what people used to do, stuff everything in the relational database management system. The nice thing here about AWS is you can pick the right tool for the right job. I'm just going to go over these at a high level. I could easily do another YouTube video on this in the future, but let's look at the various database types that you could specifically optimize within AWS. From a relational database perspective, you could go with Amazon Aurora, Amazon RDS, and Amazon Redshift. So both transactional and database warehouse type analytical databases. Key value, Amazon DynamoDB for high traffic web applications, e-commerce systems, and gaming applications. In-memory databases such as Amazon Elasticache, Amazon MemoryDB for Redis. Document databases. How about Amazon DocumentDB, which, believe it or not, has MongoDB compatibility. That's awesome. Wide column, Amazon Keyspaces. Graph databases, Amazon Neptune can be used for that. Time series databases, Amazon TimeStream. What about ledger databases? There's Amazon Ledger Database Service, or also referred to as QLDB. There's a database for you that allows you to pick the right tool for the right job. In summary, AWS managed databases are the way to go. No one has time to self-manage a database. It bogs you down. It's a lot of undifferentiated heavy lifting, and it removes your time and energy from time better spent innovating on behalf of your customers. Comment below, give me your feedback on what you thought of this particular video, and let me know what type of videos you would like to see in the future in the comments. As always, I thank you for your time and attention, and I encourage you to subscribe for more AWS cloud computing best practices and well-architected tips. Thank you.